Hey everybody, we're going to be making some videos today concerning the idea or the ideas behind matrices, or a matrix would be singular, might as well go ahead and confront that now, and matrices would be plural. But we're going to talk about today what they are and a few of their basic uses and what kind of things we tend to do with them in terms of operations and whatnot. But let's go ahead and start by answering this question: a matrix. What is a matrix? And the easiest answer I can give you is it's simply no more than a rectangular array of numbers, okay? But we might as well go ahead and start by saying we often use matrices to describe a system of equations, and typically linear equations. So you hear about matrices a lot in linear algebra, or actually you hear about them, actually you use them every day in linear algebra. But let's go ahead and write out maybe a system here. So, oops, what if we say had a system and it was negative x plus 3y minus z. We'll call that like negative 3. And then how about positive x? That'll work out kind of nice. Minus 4y's, we'll add on 3z's. And why don't we say this is equal to 5? And then one more equation. How about 2x? We'll throw you a curveball here. Minus 4z. Minus 4z. That'll be important when we write our matrix here. But we'll call this 6. Okay. And so let's say we had this system of equations right here. The fact of the matter is we said a matrix is no more than an m by n dimensional array of numbers, okay? We say m by n because we denote the number of rows and number of columns. So if I were to make a matrix for this here, first things first, we use these brackets to kind of show a matrix, okay? So whenever you see these square brackets like this with numbers populating it, we say, oh, that's a matrix. But the matrix that would say correspond to the system of equations right here would just be negative 1, 3, negative 1, 1, negative 4, 3, and 2, and negative 4. And I'm actually going to stop right here. This is not all the way populated, we would say, but I just want you to notice where I'm getting my numbers from. So far, these numbers that I'm getting down here, negative 1, 3, negative 1, so like right here, okay, those were no more than the coefficients of these variable terms up here. So negative 1, 3, negative 1, okay. So really just dropping in the coefficients, and so we might as well confront this spot right here. Because we have nothing right there, we can't just leave this blank down here. So one might already suspect that we're going to fill this in with a 0, and as a matter of fact we are. Okay, so we have 0 of these y things in our third equation. And at this point I'm actually going to stop and say, again, this is still an unpopulated matrix. We haven't populated it all the way. But what I want you to see is this. If we were to leave this matrix the way it is right now, okay, and it has 3 rows, 1, 2, 3, and 3 columns, 1, 2, 3. We'll talk about the nature of rows and columns in just a moment. But we would call this a coefficient matrix because it contained no more than the coefficients of this system, okay? But we often will put, you'll see like a line or a bar here sometimes, and you can think of it as kind of being like your equal signs here, but we drop in the coefficients on the right here. And this matrix would have a special name. As a matter of fact, we refer to this as an augmented matrix, okay? So when we drop in the coefficients on the left and the constants on the right there, okay, we refer to this as an augmented matrix. And this is often how we'll represent a system of equations, okay? And so we said we'd discuss this idea of rows and columns next, okay? Well, this rectangular array of numbers currently has 1, 2, 3 rows and 1, 2, 3, 4 columns, okay? And so we can always refer to the order of a matrix, okay? It's order. And the order of a matrix, what it's doing is giving the number of rows and number of columns. What we need to know is that it's always rows by columns. And I always kind of remember that columns, you think about a column on a building, it runs, up and down. And so why not think about it kind of in a similar light here when we talk about matrices. So rows by columns. So this matrix right here, since it has 3 rows, we'd say is a 3 by 4 columns, is a 3 by 4 matrix, okay? And so we always refer to the number of rows first. That's the thing, okay? So don't forget, always number of rows first. And then columns. So we have a 3 by 4 matrix here. Definitely rectangular, okay? So we'll come back and revisit this here in a minute, but let's go really general here. We talk about a matrix, okay? And often we use an uppercase letter to denote the matrix. So I'm gonna use the letter A here. And you'll see some people write underneath matrix names sometimes A, M by N, and all they're doing really is giving the order of this matrix. But then, that's helpful sometimes. So let's talk about this. We've got this M by N dimensional array, and it's populated with numbers. It could represent a system. It could just be some matrix that you're putting into your calculator and having fun with here. But since we're calling this uppercase A, we'll populate this in general with a bunch of lowercase a's. And we do this a lot, actually. We refer to elements, individual elements of a matrix array. And so we'd start by calling this lowercase a, but I'm actually going to call this A11, okay? And so when I call this A11, I'm simply referring to the fact that this element right here is in the first row and first column. Whereas if I would have been referring to the next one over, we could say this would be A row 1, element 2. And of course, this continues on forever and ever. Now, we had assumed in the beginning that this was an M by N dimensional array. So if we were to make our way all the way over to the right, depending upon how many columns you had, we could refer to this as A, first row, and then nth column. So A1N. Likewise, if we were to proceed down, we'd say row 2, column 1, and so on and so forth until we got all the way down to row M and then column 1. And then we also kind of usually refer to the main diagonal. Let's drop in one term here. A11, this would be A22, and we could continue to proceed on down until we got to AMN. So an interesting thing to bring up here is we often refer to individual elements in here is like A, I, J. And I just didn't want people to be confused. Why are we using I and J and also M and N? Okay? And keep in mind that MN really referred to the overall dimensions or order of this matrix, okay? Whereas AIJ is in the ith row and jth column, but kind of, we usually use to represent something maybe in the middle. I know that's an assumption I should make, but I'm just kind of trying to get you to see the idea here. So one thing to bring up here while we're at it is this. What if M equal to N, okay? If M equal to N, then, okay, what we have is what we refer to as a square matrix. Okay, so a square matrix. Not a shocker. You might think, oh, it's shaped like a square, and you'd be absolutely right in saying that. And I don't know if you'd say it like that. I mean, that was kind of weird, but yeah, square matrix. Okay, and so just a few more things here. What if you had a matrix? As 1 0 0 0 1 0. We'll go binary. Okay, so this would be a one row by 1 2 3 4 5 6 columns. But this would be a 1 by 6. But it'd be important to note this is referred to as a row matrix. A row matrix. And likewise, we could have a column matrix. What if we had 1 2 3? Okay, so this would be a 3 by 1, but this would likewise be referred to as a column matrix. Column matrix. And then last but not least, my favorite, the zero matrix. Okay, so we say we got a column matrix here. We've got row matrix here. So we also have the zero matrix. So the zero matrix, as one might suspect, can be any dimension really, but we usually use the letter O to represent. O, this is the letter. Okay, so letter O. At least I think about it that way. But it's just this matrix that's populated with this entry 0. Okay, so it is populated, it's not empty. But the zero matrix. And the nice thing about the zero matrix is if you were to take some A, M by N, and of course we discover later, and add it to 0, and in this case we'll call 0 M by N, want the same dimensions, but you just get A again. And so the unique property of the zero matrix is that it's the additive identity. It'll be added to anything and not change it. So way cool, way cool. Yeah, so that's just a basic kind of primer on what a matrix is, what we use it for, the fact that we augment matrices, kind of like over here, to represent a system of equations. Okay. So in the next video, we're going to talk a little bit about elementary row operations, or things that you can do, or operations you can perform on a matrix.